Hello children, in this video we are going to cover some important topics from this chapter, Introduction to Object-Oriented Programming Concepts. So if you are following this textbook, please mark these important lines. So first topic is the different types of computer languages which are classified into low-level languages and high-level languages. And low-level languages is again classified into machine-level language and assembly-level language. We can see it later. So what is low-level language? Computer recognizes the instructions without any conversion into machine-level language. So these are not directly understood by the users. And these type of languages were used in the early computers when only the experts were able to code the instructions. So no need of converting it into any other languages. It can be easily understandable by the computer. So first category of low-level language is machine-level language. It will be always in the form of binary digits. What is binary digit? Combinations of zeros and ones. So such code we can call it as machine code or object code. So this is the main advantage of machine-level language. That means program executes fast because it is already in the form of machine-level language, that is in the form of zeros and ones. So the execution of program will be fast. But there are some limitations. We have to remember all the instructions code, and error detecting or correcting it is very difficult, and also it is a machine-dependent language. And the second category of low-level language is assembly-level language, is in the terms of mnemonics and opcodes. That means operation codes, which is known as assembly-level language. Mnemonics means this one. If you want to load a value or you want to store a value in a variable, you have to use this mnemonic. And if you want to add two values, you have to use this one. And for storing the result and for stop, halt, mnemonics, HLT mnemonic you have to use. So corresponding opcodes also you have to remember. So these are not understandable by the user, right? Can you understand anything by seeing these mnemonics? No. So for that purpose we need to convert this assembly level language into machine code with the help of a translator called assembler. Okay. So this assembly level language are not directly understood by the computer. Hence, a translator is required to convert the instructions coded in the assembly level language to its equivalent machine code. So that translator name is assembler. So advantages is it is very easier to write the instructions when we compare to the previous category, that means machine level language. And detection and correction will be very easier, and code can easily be modified. We don't need to remember all those forms in zeros and ones. So comparatively it is very easier to maintain. But some limitations are it is also a machine dependent language and the user needs to remember all these mnemonics or these opcodes. And also we need a assembler or a translator is required to convert this language into machine code. That is the main disadvantage of assembly level language. And this is the second category of computer languages. Languages allow the user to write the instructions in simple English phrases or sentences. So we can use English words and mathematical symbols. So it is very easier to learn. These are the examples you can write for a high level language. And advantages, it is a machine independent language. The instructions will be in the form of English words or phrases. So it is very easier to understand and to develop the logic part. And error detection and correction will be easier. So these are the advantages. And disadvantages, we need to translate our human readable language into machine level language. That is one of the main disadvantages here. And it is very less efficient when we compare to assembly level instructions. So we need a translator, right? So these two are the translators we use in high level language, compilers and interpreters. So we'll see what is compiler. A software that accepts the whole program written in a high level language and converts it into equivalent program in machine level language. So it is converting the whole lines of a program to a machine level language here. And the program which the compiler uses for conversion, it is known as source program or source code. And after converting, we'll get a program code, right? That we can call it as object program. The program converted into the machine level language is also known as object program or object code. So for example of compiler, you can write Fortran. And interpreter means we are converting line by line only. That is the main difference between compiler and interpreter. The software which converts the instructions written in high level languages into their equivalent instructions in machine level language. But the difference, what is the difference? Line by line or statement by statement it will take. So compilers and interpreters, we can also name it as language processors. And these are the very important differences between compiler and interpreter. Compiler, it converts the whole source program into object program at once. So if there is any errors, it displays the errors for the whole program together after the compilation. Okay, so after doing the program, if you compile for the errors, suppose if there are 10 errors, it will show 10 number of errors in the program. So, but in this type of interpreter translator, it converts the source program into the object program one line at a time. That means, if suppose there are 10 errors, first it will show the first error. Line by line it is showing. So, only after debugging the first error, we can go to the next line. So, line by line they are converting. That means, if there is any error in that line, we can correct it first. Then we'll go to the second line, correct it then we can go to the third line. So line by line it is converting, so the user will be very easy to correct the errors. Okay. And types of high level languages are there. 3 types: structure oriented, procedure oriented and object oriented language. So first one is structure oriented. You already learned that by drawing the flowchart or drawing some structures, we will solve the problems. So such languages are called structure oriented programming language. You can write these examples. And second one is procedure. Procedure means we can call it as function also, function oriented programming language. So here we are simplifying a main program into many functions. Okay, so if you take a complex program, we are dividing it into a simplest module of each functions and executing. So procedure oriented program basically consists of a list of instructions for the computer to follow, and these are organized into groups called functions. So if you are taking some data, for example, if you are taking 2 numbers and in this function you want to execute the sum of 2 numbers, execute it. And using the same function you want to execute another function subtraction, another function multiplication. So using the same data we are doing different functions here. So if you take a complex program, you need to categorize into many functions. So that will be very difficult to maintain. So in procedure oriented programming language, it's everything based on functions. It mainly focuses on functions. So you can write this example for procedure oriented programming language. So these are the characteristics. It focuses only on the functions and it shares some data, global data, and data values can keep floating from one function to another. After executing one function, we'll go to the next function. So it uses a top-down approach. Top-down means main program is classifying it into different functions. So it is a top-down structure. And some limitations are, I already said, as data values are global to all the functions, you may require to make necessary changes in all the functions. If there is any case of any change in data values, you have to make that change in functions also. So managing that updation and all, it will be very difficult. And it is not suitable to solve complex programs in real situations. And this is the third type of high-level language program, that is object-oriented programming. In the name itself, we can see we are mainly focusing on object. See, here we can see many objects, object A, B and C. So each data and its function we can wrap it together and we can keep it inside an object. That means we can consider it as a object. So each and every object we are making it into a separate under a class name, under a common class name. For example, if I am taking some objects that comes under fruits, that means banana, apple, pineapple, orange. So these are all object or data items. So everything will be come under a common name called fruits. So like that only we are separating each object, and every object consists of data and its function. Data means if I want to find the sum of two numbers, that two numbers will be my data. And if I want to find the sum, right, so function is sum here. So data will be also there and its function will be also there. So everything will be wrapped together and we can consider it as a object. And all these objects can come under a common class name. So features are, it gives importance to the data items rather than the functions. In previous procedure-oriented programming, we mainly focused on functions, but later we developed this object-oriented programming type and we are focusing the objects or data items. Both are same. Okay. And it makes the complete program simpler by dividing it into a number of objects we can create. Okay. And objects can be used as a bridge to have data flow from one function to another. So we can use these objects to find one or more functions. And the concept of data hiding. Data hiding means what? If you want to manage or if you want to make any update in this, you don't worry about other objects. So these objects will be hidden. So these data will be hidden, only this thing you need to worry about. So it will provide the concept of data hiding. It enhances the security in programs and it is highly beneficial to solve complex problems. These are the difference between procedural oriented programming and object oriented programming. It mainly focus on function. Here it is mainly focus on data. And it allows data to flow freely, but here data is restricted because some data are hidden, right? And third one, it is a top-down structure, means main program is dividing it into many functions, but here bottom-top programming approach, that means opposite of this procedural oriented programming. And next topic is basic principles of object-oriented programming, which is very important topic in this chapter. And there are 4 principles. First one is data abstraction. Data abstraction is an act of representing the essential features without knowing the background details. Suppose if you are taking a photo, what will you do? You will just click the photo and you need not worry about the internal working of the camera, right? So only the essential features, what you have to do, only that will be highlighted. The rest of the program, you can hide it. Okay, so such feature also we'll get it from this object-oriented programming, which is called data abstraction. And second one is inheritance. We are inheriting some properties from another class. Suppose you'll get some properties or characteristics from your parents, and your parents are getting some characteristics from your grandparents. So such property is called inheritance. So inheritance means to link and share some common properties of one class with the other class. Okay, for example, from this animal class, we are inheriting some properties for carnivores and herbivores. So which we can classify under this class. So this class we can call it as base class or super class. And deriving 2 classes we will get. So these classes we can call it as derived class or subclass or target. And third one is polymorphism. For example, English word duck. So it has 2 meaning. One is water bird and second meaning is duck means in cricket, it means a batsman who got out with no score. So by using a same name, we have 2 different meanings, right? That is called polymorphism. So this main polymorphism method we can achieve through object-oriented programming. See this example, volume function. So by using this same function name, we can find the volume of cuboid. We can find the volume of cuboid, cube and circle also. So if you want to find the volume of a cube, you need a parameter side of a cube. And if you want to find the volume of a cuboid, you need 3 parameters, that is length, breadth and height. So here also, if you want to find the volume of a circle, you need the parameter radius. So this is called function overloading. Function overloading is a technique to use a number of functions with the same name having different parameters. So this function overloading, we can achieve it through polymorphism. So the polymorphism is defined as the process of using a function or method for more than one purpose. And next one is encapsulation. We are wrapping up of data and function together and consider it as object. So we already discussed this concept before. So we can summarize this. These are the main benefits of object-oriented programming. Reusability, quality and performance will be there. Modularity, that means we are wrapping the data and function together in a modules, and it is very easier to handle, and we can solve complex tasks also. But there are 2 limitations in this. Testing process should be done in this type of object-oriented programming, and time consuming will be more in this type of problems. So everyone go through this chapter, study the definitions and example, and more important topic is basic principles of object-oriented programming. I hope everyone understood this chapter.